Welcome back. In this lesson, we're moving into Task Statement 1.4, where we'll explore the key concepts behind cloud economics, one of the most important areas for understanding why companies choose AWS. Here's what this task covers. Aspects of cloud economics, how cloud spending works, and how it compares to traditional IT cost models. Cost savings of moving to the cloud, and the financial benefits organizations gain with AWS. And for the skills, you'll learn how to compare fixed versus variable costs, recognize on-premises cost factors, understand licensing strategies like bring your own license, explain the concept of right-sizing, identify the benefits of automation, and understand how economies of scale help reduce costs in the cloud. By the end of this lesson, you'll understand exactly how AWS helps organizations save money, operate more efficiently, and scale without wasting resources, which is core knowledge for the exam. Let's get started. When we talk about cloud economics, we're not just talking about saving money. Cloud economics is really about increasing the business value that organizations get from technology. AWS helps companies operate more efficiently, move faster, reduce risk, and even meet sustainability goals. So let's break down the main aspects of cloud economics and why they matter. CapEx to OpEx, the financial shift. Traditionally, companies invested heavily in physical hardware, servers, storage, networking, all paid upfront. This is called CapEx, or capital expenditure. With AWS, that model disappears. You move to OpEx, or operational expenditure, a pay-as-you-go approach. This shift brings three major benefits. You don't need massive upfront investments. You avoid buying more hardware than you need. You match spending with actual usage. For businesses, that means less financial risk and more flexibility to innovate. Total cost of ownership, TCO. This is the full cost of running workloads, not just the server price. On-premises environments also require power, cooling, facilities, IT staff, hardware refresh cycles, security, downtime recovery. TCO analysis compares all of these costs to AWS. And for most organizations, the cloud becomes a much stronger financial case once you consider everything involved. Economies of scale. AWS operates at a massive global scale, far bigger than any single company could match. Because of that scale, AWS can provide lower per-unit costs and efficiency improvements. Customers benefit from these savings without needing to grow their own infrastructure. So instead of investing millions to reach the same scale, you simply use AWS and let them pass those savings to you. Resource optimization. One of the biggest financial advantages in the cloud is how easily you can optimize your resources. This includes three key ideas. Right-sizing. Instead of guessing server sizes years in advance, you choose the exact instance type or storage class your workload needs right now, and adjust anytime. Elasticity and auto-scaling. Your resources automatically scale up when demand increases and scale down when traffic drops. This prevents over-provisioning and avoids paying for idle capacity. Pricing models. AWS gives you multiple ways to pay depending on your workload pattern. On-demand flexibility, no commitment. Reserved instances and savings plans reduce costs for predictable workloads. Spot instances deep discounts for flexible or fault-tolerant jobs. These options allow organizations to balance cost and performance in a way traditional data centers cannot. Increase productivity and agility. Cloud economics isn't only about financial savings, it also impacts how teams work. When AWS takes care of the infrastructure, teams spend less time maintaining servers and more time building features and delivering value. Rapid provisioning means developers get resources in minutes instead of waiting weeks, which improves innovation and shortens release cycles. Operational resilience. AWS also provides built-in resilience, things like multi-OS architectures, automated backups, disaster recovery, and security tools. These features reduce downtime and business risk, which are major hidden costs of on-premises operations. Cloud Financial Management, CFM FinOps. Managing cloud cost is a discipline on its own. AWS provides frameworks and tools to help organizations track, optimize, and forecast their cloud spend. This includes cost allocation tags, budgets, regular cost reviews, and collaboration between finance and IT. FinOps ensures teams not only use the cloud, but use it efficiently. Finally, sustainability is becoming a central part of cloud economics. AWS designs its infrastructure for energy efficiency, and because workloads are shared across large data centers, the total carbon footprint is much lower than in traditional environments. For many companies, moving to AWS is now part of their overall sustainability strategy. So in summary, cloud economics is about far more than lowering costs. It's about using AWS to run your business more efficiently, more resiliently, and more sustainably, while enabling teams to innovate faster. Alright, so at this point, go ahead and pause the video. Take a moment to read the question carefully, and try to answer it on your own. Once you've made your choice, resume the video. In this question, a company wants to avoid large upfront hardware purchases and reduce the risk of over-provisioning. So immediately, that tells us they're trying to move away from the CapEx model, buying big, expensive hardware upfront, and instead shift toward more flexible spending. But they also want to compare the long-term financial impact of staying on premises versus migrating to AWS. And that includes indirect costs like downtime and IT labor. When a question mentions comparing all costs, not just hardware, that is a big clue. This points directly to total cost of ownership, TCO, analysis. TCO is the cloud economics principle that helps organizations evaluate the full financial picture, direct and indirect costs, to make a business case for migration. When you're ready, go ahead and pick your answer. Great, now let's walk through the correct answer together. The right answer to this question is performing a total cost of ownership, TCO, analysis. Here's why this is the best choice. When a company wants to avoid large upfront hardware investments and reduce the risk of over-provisioning, they're really trying to understand whether staying on premises makes financial sense compared to moving to AWS. And that's exactly what a TCO analysis is designed to do. TCO looks at all the costs involved, not just the obvious hardware purchases, but also the hidden costs that often get ignored, such as downtime, security incidents, IT labor required to maintain hardware, unused or idle capacity. By comparing these costs between on-prem and AWS, the TCO model gives organizations a clear, data-driven view of which option is more cost-effective in the long run. So in this question, the company wants to understand the true financial impact of cloud migration, and the only option that supports that kind of analysis is the total cost of ownership. In short, TCO helps you make smarter financial decisions by revealing the full picture, not just the price tag. Now that we understand how cloud economics are evaluated with tools like TCO analysis, let's move into one of the most important outcomes of that evaluation, the cost savings of moving to the cloud. Now, let's talk about one of the biggest reasons organizations move to AWS. Cost savings. When companies migrate to the cloud, they're not just looking to modernize their technology, they're looking to spend smarter. And the impact is significant. On average, organizations report 20% to 31% reductions in total infrastructure costs, and the top performers can save up to 47%. Let's break down where these savings actually come from. Elimination of capital expenditure, CapEx. Traditionally, businesses have to buy servers, storage devices, networking equipment, all of it upfront. That's a big, risky investment. With AWS, that model disappears. Instead of buying hardware, organizations shift to OpEx, paying only for what they use. No more massive upfront purchases, no more idle servers, and no more wasting budget on hardware that might not be fully utilized. Reduced infrastructure costs. This is where cloud economics really shines. AWS helps optimize costs across compute, storage, and networking. Compute savings. AWS Graviton processors, serverless services like Lambda, and pricing models such as savings plans and spot instances can reduce compute costs by up to 63%. Storage savings. By choosing the right storage tier, for example, S3 Intelligent Tiering or Glacier, organizations can cut storage costs by up to 69%. Networking savings. Eliminating on-premises networking equipment and using solutions like AWS Direct Connect reduces both complexity and cost. Increase staff productivity. AWS automates a huge amount of operational work: patching, backups, scaling, maintenance. All the things teams used to spend hours or days managing. When those tasks disappear, teams can finally focus on innovation. In fact, studies show a 47% increase in staff efficiency after moving to AWS. That's time redirected toward features, customers, and business growth. Improved operational resilience. AWS gives you high availability, built-in security controls, and strong disaster recovery capabilities right out of the box. This leads to fewer outages and faster recovery, which translates directly into cost savings. Organizations have reported a 69% reduction in unplanned downtime, and anyone who has worked in IT knows downtime is expensive. Optimize capacity. In the cloud, you're never stuck guessing capacity again. No more buying extra servers just in case. With AWS elasticity, you scale up when you need it and scale down when you don't. This alone eliminates one of the biggest sources of waste in traditional IT. So overall, migrating to AWS unlocks savings not just from cheaper infrastructure, but from smarter operations, better productivity, and reduced business risk. It's a combination of financial efficiency and technological advantage that continues to attract organizations of every size. Alright, so at this point, go ahead and pause the video. Take a moment to read the question carefully, and try to answer it on your own. Once you've made your choice, resume the video. Next, I'll walk you through a few clues to help you identify the correct answer. Alright, now let's walk through this question together. The scenario tells us that the company's IT staff is spending most of their time patching servers and maintaining hardware. After a recent outage, leadership wants three things: less downtime, better reliability, more time for innovation instead of routine maintenance. Whenever you see a combination of reducing maintenance burden, minimizing downtime, and improving reliability, this is a huge clue pointing toward two major AWS migration benefits. 1. Increase staff productivity. Because moving to AWS removes the heavy lifting of hardware maintenance, patching, and routine operational tasks, IT teams can finally focus on innovation instead of babysitting servers. 2. Improved operational resilience. AWS provides built-in high availability, fault tolerance, and automated recovery capabilities, dramatically reducing the risk of outages like the one mentioned in the question. The other answer choices don't align with what the company wants. Higher spending on new cooling systems. This actually increases cost and keeps them on premises. Predictable budgeting with hardware refresh cycles. Still keeps them tied to physical hardware. Greater dependence on manual patching. The opposite of what they want. So, the only answer that addresses all the business goals in the scenario is increased staff productivity and improved operational resilience. Great job! Let's take this a step further. To really understand cloud economics, we need to see how the cost structure changes when moving from on-premises to AWS, from big fixed expenses to flexible, variable cloud costs. Before we talk about the AWS cost model, let's start with how things work in a traditional on-premises environment. In an on-prem setup, most of the costs you deal with are fixed costs. That means organizations have to spend a large amount of money upfront, long before they know exactly how much capacity they'll actually use. These fixed costs, also called CapEx or capital expenditure, include big investments such as buying physical servers, storage arrays, and networking equipment, building or leasing data center space, paying for annual software licenses, maintenance contracts, and support agreements. The challenge with this model is that the business has to make these investments regardless of real usage. Even if the servers run at 20% utilization, the company still pays for 100% of the hardware. Now, what are the drawbacks of operating this way? First, high risk. Organizations must predict future demand years in advance. And if those predictions are wrong, they either over-provision, which wastes money, or under-provision, which hurts performance and reliability. Second, low agility. Scaling in an on-premises environment is slow. If you suddenly need more capacity, you can't just click a button. You have to buy new hardware, wait for delivery, install it, configure it, sometimes taking weeks or months. And third, long-term commitment. Once a company buys the hardware, the capital is locked in. These assets also depreciate over time, meaning they lose value even if they aren't being used efficiently. So in short, the traditional fixed-cost model limits speed, flexibility, and financial efficiency, exactly the problems cloud computing is designed to solve. Now that we've seen how traditional on-premises environments rely heavily on fixed costs, let's shift to the cloud model, specifically, how AWS introduces variable costs. This is one of the biggest mindset changes in cloud computing. In AWS, companies no longer need to guess future demand or purchase hardware years in advance. Instead, AWS uses a consumption-based pricing model, where you pay only for the resources you actually use. This aligns IT spend directly with real business activity. So what exactly does variable cost mean in AWS? It means your expenses scale up or down automatically based on usage. For example, compute usage. You're billed only for the compute time you consume on EC2, per hour or even per second depending on the instance type. Storage. You pay for the actual amount of data stored in Amazon S3, and that cost can dynamically change as your data grows or shrinks. Data transfer. Network data transfer is billed based on the volume of data moving in and out of AWS services. This model unlocks several powerful benefits. First, flexibility and agility. If your application suddenly needs more capacity, maybe there's a spike in traffic, you can scale up instantly. And when demand drops, AWS scales back down, ensuring you don't pay for resources you're not using. Second, reduced risk. Because you're not committing to large, upfront infrastructure purchases, forecasting errors become far less costly. Even if your estimate is off, the cloud automatically adjusts. Third, no upfront capital required. Instead of tying up money in depreciating hardware, companies can reinvest that capital into innovation, product development, hiring, growth, things that actually move the business forward. This is why AWS is such a strong fit for organizations that want to stay lean, adaptive, and financially efficient. You move from a world of buy it just in case to a world of use it only when needed. Ultimately, variable costs give you control, flexibility, and financial predictability, which simply aren't possible in a fixed-cost, on-premises model. Alright, so at this point, go ahead and pause the video. Take a moment to read the question carefully, and try to answer it on your own. Once you've made your choice, resume the video. Next, I'll walk you through a few clues to help you identify the correct answer. Alright, before we reveal the correct answer, let's walk through a few clues to help you think about this question the right way. The scenario describes a startup that wants to scale rapidly during peak seasons, reduce costs during slow periods, avoid long-term infrastructure commitments, pay only when resources are actually in use. These clues should immediately make you think about cloud elasticity and consumption-based pricing, two concepts that belong to the variable OpEx model in AWS. Now let's look at the options and identify the correct answer. Correct answer: variable OpEx costs that scale directly with resource consumption. This is exactly how the AWS cost model works. Under the AWS pay-as-you-go model, you pay only for what you use. Your costs increase when usage increases. Costs automatically decrease when usage drops. There is no upfront hardware investment. No long-term commitment is required. This perfectly matches the startup's needs: flexibility, agility, and cost control. Why the other options are incorrect? Fixed CapEx costs that require upfront hardware planning. This is the opposite of what the startup wants. CapEx involves buying servers, storage, networking gear, all upfront, and cannot scale dynamically. You pay regardless of usage. Predictable on-prem pricing through annual hardware leases, still an on-premises model, and not elastic. Leases lock companies into fixed annual costs, even during slow seasons. This doesn't allow costs to shrink when usage is low. Strict multi-year licensing contracts for server software, another model with long-term commitments, exactly what the startup wants to avoid. These licensing agreements reduce flexibility and don't support the pay-as-you-go structure needed for dynamic scaling. So the key takeaway is this: if a business wants flexibility, avoids upfront spending, and wants costs to scale with usage, then variable OpEx, the AWS Cloud model, is the perfect match. Great job! Let's continue to the next topic. Now let's start breaking down the real costs behind traditional on-premises environments. When a company manages its own data center, the first major category of spending is hardware and infrastructure costs. And these costs go far beyond just buying a few servers. Let's walk through what this really means in practice. 1. Initial procurement, CapEx. In an on-premises model, organizations must purchase hardware upfront. This includes physical servers, storage arrays, networking switches and routers, firewalls and security appliances. These are capital expenditures, meaning the company must spend a large amount of money on day one before a single application even runs. For example, if a business expects its application to grow over the next 3 years, they must size the infrastructure today for future demand. That means buying more hardware than they currently need, just in case. And if the prediction is wrong, they either end up over-provisioned and wasting money, or under-provisioned and unable to scale. Everything purchased also depreciates over time, which adds long-term financial pressure. 2. Hardware refresh cycles. Most companies follow a 3 to 5 year hardware refresh cycle. This means that every few years, all aging equipment must be replaced, migrated, tested, installed, and eventually decommissioned. This cycle is expensive, time-consuming, and disruptive. Here's a real-world example. A company with 50 servers might need to replace them every 4 years. That means budgeting hundreds of thousands of dollars regularly, even if the business is not growing. In addition, refresh cycles require detailed planning. Scheduling migrations during maintenance windows, coordinating downtime, purchasing new hardware, securely disposing of old equipment. This adds both financial cost and operational overhead. On-prem infrastructure costs are not just about the initial purchase. They are a continuous cycle of paying upfront, maintaining and powering equipment, replacing aging systems, planning migrations, managing hardware failures. All of this keeps teams busy and reduces their ability to focus on innovation, and this is one of the main reasons companies shift to the cloud. Next, let's talk about one of the most overlooked but extremely expensive parts of running an on-premises environment: facilities and utilities. When a company owns and operates its own data center, the responsibility goes far beyond buying servers. You also have to house those servers, power them, cool them, and protect them. And all of these requirements come with real and ongoing costs. Let's break this category into 3 major components. 1. Physical space. On-premises infrastructure requires dedicated floor space, whether it a full data center, a server room in an office building, or even rented colocation space. This space comes with recurring expenses such as rent or mortgage costs, real estate taxes, physical security systems, security staff, restricted access areas. For example, a company renting a 500-square-foot server room in a commercial building may pay thousands of dollars every month just to keep servers in the room, even before considering power or cooling. And because servers must operate in controlled environments, companies often pay extra for reinforced floors, specialized wiring, fire-resistant construction. All of this contributes to the operational cost burden. 2. Power and cooling. Servers need electricity, lots of electricity, and they run 24/7. But what many organizations don't anticipate is that cooling the environment often costs as much as the power used by the servers themselves. On-premises environments require high-capacity air conditioning systems, chilled water or HVAC units, UPS, uninterruptible power supply, systems, backup generators, battery replacements. A real-world example. A medium-sized data center can spend hundreds of thousands of dollars per year simply on cooling, because hardware generates a tremendous amount of heat. Add to that the cost of keeping everything running during power outages, diesel for generators, maintenance contracts, and periodic testing, and power becomes one of the largest long-term expenses in a traditional environment. 3. Maintenance and building operations. The facility itself also needs constant care. This includes fire suppression systems like FM200 or CO2-based systems, insurance to cover physical assets, security systems such as biometric scanners, cameras, and alarms, building maintenance and inspections, staff to manage physical access or monitor the environment. For example, specialized fire suppression systems used in data centers can cost tens of thousands of dollars to install and must be inspected regularly. Insurance premiums are also higher because of the expensive equipment stored inside. When companies compare on-premises costs to AWS, they often underestimate the facilities and utilities category. But this is one of the biggest advantages of cloud computing. AWS absorbs all of these costs, and customers only pay for the compute, storage, and networking they actually use.